A matrix is a collection of information in number form. It is always stored in rows and columns. Each of the numbers in a matrix is referred to as an element or a member of the matrix. Right in front of our screen, we are looking at a form of a matrix. It's a matrix that is in the form of M by N, meaning that it's having M rows and N columns. In this tutorial, we'll be looking at the types of matrices there are. This is Kisembo Academy, and thanks for tuning in. So right in front of us, we are having elements in a matrix. This is element A, but they are in forms of M rows and N columns. By rows, I mean these are the rows, and then the columns are those ones. So when I say A11, A subscript 1, it means that it is in the first row and first column. A21, 21 simply means that it is in the second row but in the first column. And this element here is in the third row but in the first column. This element here is in the second row and second column. This one is in the third row and second column. That is how we categorize, or that is how we name the elements in the matrix. We arrange them in terms of rows and columns. And this, therefore, is a matrix of a 3 by 3, a 3 by 3 matrix. A 3 by 3 matrix means that it is having 3 rows and 3 columns, as we shall see later on. Now let's look at the types of matrices. We have what we call the row matrix. These ones only have rows. For example, this 3, 5, ABC, 9, 4, 1, they only have rows. We have what we call the column matrix. These ones only have columns, like 3, 5, 2, 3, 3, ABC. These ones are just columns. Then we have the square matrix. In a square matrix, we have the same number of rows and columns to just make the square, just like we all know that a square has a property that it has the same number of, a square has equal lengths in all its sides. So if you look at this, it's having 1, 2 rows and 1, 2 columns. If you look at this matrix, it's having 1, 2, 3 columns and 1, 2, 3 rows. So the same number of rows and same number of columns makes it a square matrix, just like this also. The columns are 1, 2, 3, 4, and the rows are 1, 2, 3, 4. So this is a 4 by 4 matrix because it has 4 rows and 4 columns. This is a 3 by 3 matrix because it's having 3 rows and 3 columns. This is a 2 by 2 matrix because it's having 2 rows and 2 columns. And because they are having the same number of rows and the same number of columns, we call them square matrices. We have what we call the rectangular matrix. The rectangular matrix has different number of rows and different number of columns, just like a rectangle. The length of a rectangle is not the same as the length as its width. They are different sizes. So like here we are having 1, 2 rows and then 1, 2, 3 columns. So this one is a rectangular matrix, same as this. It is having 2 columns and 1, 2, 3 rows. So because the number of rows and columns are different for these two matrices, for every matrix, then it qualifies to be called a rectangular matrix. Then we have what we call a null or zero matrix. A null or zero matrix is simply a matrix whose elements are all 0, as simple as that. Then we have what we call the identity matrix. An identity matrix is simply a matrix with the elements in their leading diagonal being 1. If you look at this, we have 2 diagonals. We have this diagonal and that diagonal. This diagonal is what we call the leading diagonal. And if all the elements in the leading diagonal are 1, then that is called an identity matrix. All the elements are 1 and the rest are zeros. If you look at this matrix, we have that diagonal and that diagonal. What we call the leading diagonal is this one. That's the leading diagonal. Now, if all the elements in the leading diagonal is 1, 1, 1, and the rest of the elements are all zeros, then that is called a unit or identity matrix. Let's take an example here. 4 senior 3 students. 4 senior 3 students, Agaba, Mbazira, and Mororwa, and Kaleba, were asked how much pocket money they received. During term 1, A received 20,000, M received 50,000, and C received 10,000, and K received 20,000. During term 2, A received 20,000, M received 90,000, C received that, and K received that. They're asking us to represent this information. Represent this information as a 4x2 matrix, and then Roman 2 as a 2x4 matrix. We begin. So we shall begin by first of all summarizing our question. They're telling us that there are 4 senior 3 students. These 4 senior 3 students are Agaba, we call him A, Mbazira, Mororwa, which is C, and Kaleba, who is K. Those are the 4 students, and they were asked how much pocket money each received. So these are the 4 students. How much pocket money did they receive? Now during the first term, A received 20,000. So we shall say during term 1. So during the first term, A received 20,000. M received 50,000. This one received 50,000. C received 10,000. C received 10,000. And K received 20,000. And K received 20,000. That is in the first term. Then what about during the second term? During second term, A received 20,000. So let's look at the second term. Remember, we're just summarizing the question. So during the second term, A received 20,000. During second term, A received 20,000, M received 90,000. Then C received 20,000, and K received 10,000. So after summarizing the question, we're supposed to present this information, 1 as a 4x2 matrix. This is the information now we have extracted from the question, and we are being asked to represent it as a 4x2 matrix. Now when they say represent this matrix as a 4x2 matrix, it simply means that this matrix must have 4 rows and 2 columns. Just like we had intimated earlier, that an M by N matrix has M rows and N columns. So it means when they're talking about a 4x2 matrix, it means it's having 4 rows and 2 columns. So it means that we are going to design these figures in such a manner that we are having 4 rows and 2 columns. So in making a 4x2 matrix, we rearrange these figures in such a way that we are having 4 rows. So if you look at this, we have 1, 2, 3, 4 rows and 2 columns. 1, 2 columns. So this is a 4x2 matrix. And we rearranged this, meaning that the A is here, this M is there, this C is here, and this K is right here. So, and then the terms, the first term monies are here, then the second term monies are here. That's a 4x2 matrix. So it means that a 2x4 matrix will be the reverse. It will be 2 rows, which is that, and then 4 columns. 1, 2, 3, 4. And that's a 2x4 matrix. This brings us to the end of this video. For more videos, I encourage you to subscribe to this channel and also to share on other platforms. I hope you watch the next video. For Kisembo Academy, this is Arnold Ranga Kuramia.